All right, so in the very last lecture, we reviewed two of the three dividend models. Okay, so we have already looked at the zero growth model and the constant growth model. And today we're going to review the differential growth model. In some textbooks, it is also known as the variable growth model. Okay, either way is that when you see the dividend growth rate, there's more than one dividend growth rate, then it should be obvious that you have variable growth model, and therefore the fastest way to solve for the P0 is to follow that three-step approach. In some textbooks, introductory textbooks, they may show you how to do this in 4 steps, but really that's unnecessary. So I will show you the fastest way to do this. Okay, so the first numerical example will be review, but we do have a little brain teasers. Okay, solving for D0 or D1, then also solving for the R by using the variable growth model. Okay, so let's start with the review. Okay, so the basic one is review on slide number 25. So let's read this together. You assume that dividends will grow at different rates in the foreseeable future and then grow at a constant rate thereafter. So let me close the door. Okay, so in the first two cases or the two earlier models, we saw that typically to decide which dividend model is more appropriate for your analysis, we typically look at the historical dividends, right? We're trying to use history to predict or to project into the future. So we'll first of all calculate our annual dividends. So we'll graph our annual dividends after that. Okay, x-axis is year, well, y-axis is your annual dividend. So once you graph the annual dividends, if the annual dividend graph looks like this, then congratulations, you have the easiest scenario, right? It's obvious that the dividends are always the same. Therefore, you should use case 1 or model 1, the zero growth model. Well, if when you graph the annual dividends, well, ideally for the second case, you will have a perfectly straight line like that. But in the real world, we don't live in a perfect world. Okay, so you will rarely ever see a perfectly straight line going upward. Okay, so even if the dividends are just increasing but at a relatively constant rate, that's good enough for us. Okay, so in that case, it may indicate that we can use the second model, which is the constant growth equation, to solve for the P0. But when you graph the annual dividends, as some of you probably saw that in the Finance 332 project, if the annual dividend graph looks like that, there's no pattern, or maybe it may look like humped. Oops, sorry. Well, it may be humped that looks like this. Then obviously model 1 and model 2 are not appropriate. And it doesn't seem like a rational pattern either. Okay, if you cannot identify a pattern in the historical dividend, then chances are you will have to do a little Google search. Okay, try to find out what dividend policy that the company has. Okay, in this case, you can no longer use history to project into the future. So you have to do a little Google search on this company and see if you can find out what the future dividends are going to look like. So if you find that there's more than one dividend growth rate, okay, so that's the biggest hint there. When you can see more than one dividend growth rate, then we have model 3, okay, variable growth scenario. So we have to follow the 3-step approach. Okay, step 1 is to estimate all of the future dividends until the growth rate becomes constant. Okay, now this is the quickest way. Okay, so if the growth rate becomes constant in year 4, once you find D1, D2, D3, and D4 in step 1, you don't have to find D5. You could if you want, but you're wasting your time. Okay, the truth is that if you calculate additional dividends that are unnecessary, provided that you still execute your steps 2 and 3 correctly, you will still get the correct answer at the end. Okay, but to be efficient, to not waste time, once you find the dividend, by the time that the dividend growth rate becomes constant, you can stop step 1 and move on to step 2. So step 2 is once we find that a dividend based on the constant growth rate, we can use that dividend to plug that into the constant growth equation. So apply the constant growth equation to the last dividend found in step 1. And what is the constant growth equation? That is this equation that we use for the second model. That is this one. Okay, this is the constant growth equation. Okay, from the constant growth model. Okay. And step 3 is we're going to use all of the relevant cash flows that we have calculated from steps 1 and 2 to find that net present value. Well, this net present value is the P0 or the intrinsic value that we are solving. Okay, so let's look at this actual numerical example. Did I record? Yes, I did. Okay, just making sure. Okay, so a common stock just paid. So if this dividend has been paid, then we know by definition, this is our D0, or also known as our current dividend. And it is equal to $2 per share. So the dividend is expected to grow at 8% for 3 years. So based on that information, we know that our G1 growth rate in year 1 equals to G2 equals to G3. Right? Growth rates in year 1 and 2 and 3, they are all the same. And it is 8% per year. And then it will grow a 4% in perpetuity. Okay, 4% in perpetuity. And that means that our G4 growth rate in year 4 and after will be equal to 4% per year. Okay, so that implies that the growth rate becomes constant in year 4. So what is the stock worth today? So we're solving for P0. Okay. Based on 12% discount rate, this is our R. Okay. So when more than one growth rate is given to us, it should be very obvious that we have variable growth scenario here. Therefore, we have to use the 3-step procedure. So the step 1, it says that we're going to calculate all future dividends until the growth rate becomes constant. Okay, so the growth rate becomes constant in year 4. That means we have to calculate D1, D2, all the way to D4. And once we find D4, when the growth rate becomes constant, we can stop in step 1. So how do we find D1, for example? Well, D1 based on the growth rate, based on G1, we know G1 is equal to, based on here, 8%, right? So that is telling us that the dividend in year 1 will be 8% higher than the previous dividend, which is D0. So using that logic, we know D1 equals to D0 times 1 plus G1. Just so we're clear, if you're solving for D1, you have to plug in G1, okay? If you're solving for D1, you need to make sure to plug in G1. So what is our D0? $2. So times 1 plus G1, G1 is 8%. So 2 times 1.08 will give us $2.16 as our D1. Okay, D0 is the $2. Okay, G1 is the 8%. Okay, so 2 times 1.08 will give us $2.16 as our D1. Now, how do we solve for D2? D2 will be calculated starting with the previous dividend. If we're now solving for D2, the previous dividend will be D1. Okay, then we're going to multiply it by 1 plus G2. Okay, so again, to make sure to match the timing, if you're solving for D2, you need to plug in G2. So what is our D1? We have just calculated our D1, right, which is this number. Okay, so we'll start with the 2.16, which is our D1 that we have just calculated. And we multiply by 1.08 because G2 is 8%. So I will bring up my calculator now, okay? Oops, there we go. Okay, so 2.16, that is my D1. I will multiply it by 1.08. So my D2 equals to 2.33, $2.33. Now, when I write down the number, I can round it off to the nearest cent because we're talking about money. But when I do my calculation, make sure that you do not round off any intermediate calculation. Okay, so do not round off anything. So that means when I calculate for the D3, I will have to use this output here. Okay, so how do I find D3? Again, we're going to start with the previous dividend, right? So in that case, it will be your D2, right? The previous dividend. Then we multiply it by 1 plus G3. Okay, so again, to make sure that if you're solving for D3, you have to plug in G3. So make sure to match the timing, okay, of your growth rate. So my D3 is equal to D2. My D2 is this number, okay, $2.33. Multiply by 1.08, since my G3 is 8%. So I'll go ahead and use this output times 1.08. And that will give me 2.52, $2.52. Again, even though I'm copying down with the rounded off number, but in my calculation, I do not actually round off anything. Okay. Now D4, one last one. D4, how do we solve for D4? We will again start with the previous dividend, which is in this case D3. Then we'll compound it or multiply it by G4. Okay. Again, make sure to match the timing of your dividend with the timing in your growth rate. So D4 equals to D3, which is the 2.52, then times 1 plus the G4. G4 is here, 4% on the right-hand side. Okay, so times 1.04. So again, to avoid a rounding error, I will use this output that I have in the calculator and multiply it by 1.04. Okay, so that gives me, now in the very last dividend, because we're getting ready to use that constant growth equation, do not round off anything. This minor rounding error can cause you big problem later. 2.6202. Okay, 2.6202. Let me change the color. 2.6202. Okay, so that is step one. Okay, find all future dividends until the dividend growth rate becomes constant. Now, step two. We know that, okay, once the dividend growth rate becomes constant in year 4, given that we have D4, if we plug that into the constant growth equation, we can solve for P3, okay? Given D4 in the numerator, if we plug that into the constant growth equation, we can solve for P3, stock price in the period before. So the denominator is just what? It's just R minus G, but with more than one growth rate, which G do we use? If you're using D4 in the numerator, you make sure to plug in G4 in the denominator. Okay, so if I plug in my numbers, my D4 in the numerator is the very last dividend found in step 1, okay, which is 2.6202. I'll divide it by R of 0.12 minus my G4, that's 0.04. So my denominator, 12% minus 4% is equal to 0.08. Okay, so I can just use this output that I already have as my numerator, and I'll divide it by 0.08 equals. So my calculation tells me that in 3 years, or by the end of year 3, I can sell the stock at $32.75. I can sell my stock in year 3 at $32.75. So now we go back to the very first numerical example that we covered in this chapter, which tells us that if you're able to obtain both dividend and stock price information for a future date, in this case, if we're able to find out what your P3 is, we will assume that we sell our stock at the end of year 3. Okay, so that example is not the exact same numbers, but it is here, okay? On slide number 15. Oops, eraser, there we go. Right, in the very first numerical example of this chapter, we say that if we are able to obtain both information, stock price for a future date and the dividend information, and in this example, we find the stock price 2 years from now is $20. So we assume that we will sell the stock at the end of year 2 at this price. So once you sell the stock, the dividends paid after that, in this case in year 3, that is not a relevant cash flow. right? So we just use relevant cash flows, discount them back to the net present value. Well, that net present value is your P0. And we're going to do exactly that again here, okay? So let me go back to the right slide. Oh, here we go. Okay, so going back to this numerical example, in steps 1 and 2, we have calculated the dividends. In step 2, we have calculated that 3 years from now, we can sell our stock at this price. So we're going to assume that at the end of year 3, we will actually sell our stock at this price. Okay, so once we sell the stock at the end of year 3, will we still receive the will we still receive the dividend in year 4, which is $2.62? Will we still receive D4? No, we will not. So the very last dividend found in step 1 is not a relevant cash flow when we have to find the net present value in step 3. Okay. So why did we waste any time in step 1 to find the D4? Well, we did not waste any time. This is the most efficient way to solve for the P0. We had to calculate for D4 so that we can plug in the D4 in step 2 to find the P3, okay? So we did not waste any time. But when we find the NPV, we need to recognize that in step 2, once we sell the stock at $32.75 in year 3, that's the end of the cash flows. We don't have any other relevant cash flow after that. So our cash flow 1 is how much? The $2.16 of dividend. Okay, so if I buy the stock now, in year 1, I will receive $2.16 in dividend. In year 2, I will receive $2.33 of dividend. Right, in year 3, that's when I'm selling my stock. So recall that the very last relevant cash flow always has 2 components. You include the dividend and the stock price. So it is dividend for that period, in this case, period 3, plus stock price for this period. So that'll be our P3. So what is our cash flow 3? D3 is $2.52. Well, P3 is the step 2, $32.75. So if I add these 2 numbers together, you'll be $35.27. Okay, $35.27. So we'll use those cash flows to find the NPV. Well, this net present value is the P0, the intrinsic value that we are solving as the unknown. So let me bring back my calculator and move it to the left so we can see. There we go. So to calculate net present value, we need to first of all enter the relevant cash flows, right? So CF, second, and clear work to delete all of the cash flows that you have entered for other problems. So cash flow 1, 2.16. It occurs only one time, okay? So we can just scroll down twice to enter cash flow 2. 2.33 or $2.33, enter, down arrow twice. My cash flow 3, if I want to double check my calculation, I can do that calculation here. 2.52 plus 32.75. Let me move this out of the way. Okay, so 2.52 plus 32.75 equals, okay, so it is 35.27, $35.27. So I will now press enter. Now to calculate for the NPV or P0, I press the NPV, enter my discount rate, and we're told that the required return or discount rate is 12%. So I'll press 12, press enter, down arrow for just one time. When we see the NPV on the screen, we'll press compute. So this is the final answer, $28.89. Okay, so this is the intrinsic value per share. So that's the highest price a rational investor should be willing to pay when buying this stock right now. Okay, so if the same stock is priced at $32 per share, you should not buy, okay, because you'll be overpaying for this asset. That's assuming your calculation and all the information that you have here is accurate. Okay, so that's the basic differential growth example. So let's look at the next 2 examples. Okay, so rather than solving for P0, what if I want you to solve for D0 or D1? So I'm going to erase this. So to keep it simple, this example also uses the same set of numbers. Okay, so I'm going to keep those some of the information there because we're going to be reusing the same information. So what is the current dividend? What is the current dividend? That means we're solving for D0 as the unknown. Okay, if the current stock price is 28.89 cents, so remember that we can only solve for one unknown at a time, right? So if I need you to solve for D0 as the unknown, I have to give you every other information, including the P0. Okay, this is your P0 or your NPV. Okay, $28.89. So dividend is expected to grow at 8% for 3 years. That's 8% per year for the first 3 years. And that's G1 equals to G2 equals to G3. That is 8% per year. Then it will grow at 4% in perpetuity. So again, that implies that G4 and after will be 4% per year, assuming the same 12% discount rate. Okay, so to solve for D0 as the unknown, again, we'll have to figure out, well, which model do we need? And it should be obvious that when more than one growth rate is given to us, we'll have variable growth model. Okay, we'll have variable growth scenario, and therefore we have to use that 3-step approach. So what is step 1? Step 1 is to find all of the future dividends until the growth rate becomes constant, right? The same 3-step approach that we saw here on 2 slides earlier. Oops, there we go. Okay, so since the dividend growth rate will become constant in year 4, right, it's 4%, that means step 1, we still need to find D1, D2, D3, and D4. Except that we don't know what D0 is. Remember that D0 is the unknown that we're trying to find, okay? So how do we find D1 when we don't even know what D0 is? We'll assume that the D0 is the X that we're trying to find as the unknown, and we're going to leave that X in every step along the way. So for example, D1 here equals to D0 times 1 plus G1, right? We don't know what D0 is, that's fine. We'll leave it in there, okay, as the X, as the unknown. So you'll be D0 times 1 plus, my G1 is what, 8%. So I will multiply it by 1.08. D0 times 1.08. Well, A times B equals to B times A. So that's the same as 1.08 D0, which is 1.08 times D0. Again, just imagine, picture that the D0 is the X that we're trying to find as the unknown. Now, step 1, to solve for the next dividend. D2, we're going to start with the previous dividend, right? So we'll have to start with D1, then we multiply it by 1 plus G2. So what is our D1? D1 is this number, okay? It's a 1.08 D0. So 1.08 D0 multiplied by 1 plus G2. Our G2 is still 8%, so times 1.08. And guess what? This is the same as, we'll assume temporarily ignore this D0, okay? We'll temporarily ignore this D0 there. So we'll use this 1.08 multiplied by this 1.08. So let me bring up my calculator. So I use this first 1.08 multiplied by the second 1.08 by temporarily assuming that the D0 does not exist in there, okay? So that means my D2 equals to this many times D0. So 1.1664 D0. That is my D2. Let me draw a line so we know that's D2. So what is my D3? We'll again start with the previous dividend, right? So if we're solving for D3, my previous dividend will be my D2. So we use D2 times 1 plus G3. And what is my D2? D2 is this number, okay? 1.1664 times D0. So I will start with that 1.1664 D0 times 1 plus G3. My G3 is again 8%, so times 1.08. I will again temporarily assume that this D0 here does not exist. So I will use this first number, which is what I have in my calculator, and I will multiply by 1.08. Okay, I go ahead and use this output, multiply by 1.08 to avoid rounding error. Okay, so that gives me D3 equals to 1.2597 D0. Okay. Let me move this downward. Oops. Okay, one more, because dividend growth rate becomes constant in year 4, right? So we have to calculate all future dividends until at least year 4. So what is D4? We'll start with, again, with the previous dividend. Okay, so if you're solving for D4, we'll have to start with D3, which is this number. Okay, we'll multiply by 1 plus G4. So 1.2597 D0 multiplied by 1 plus G4. My G4 is 4%, so times 1.04. So I will again use this output that I already have in my calculator. Okay, then multiply it by 1.04. Okay, so my D4 equals to 1.3101, and I know that the D0 is still there. Okay, so that is the end of step 1. Find all future dividends until the dividend growth rate becomes constant. Okay. So now what is step 2? Step 2 is that once we know that the dividend growth rate will become constant in year 4, we can plug in D4 into that constant growth equation. So given D4, if we plug that into the constant growth equation, we can solve for P3. Okay, it's the stock price, the period before. So given D4, we solve for P3, right? Just like the model 2, the constant growth equation. So let me bring back that equation here. Model 2, the constant growth equation is this one. Okay, given D1 in the numerator, you can solve for P0. Okay, if you don't quite remember everything, you can always go back to review the lecture, the previous lecture. Okay, so but one more thing. Which G should we plug in here? We need to know that given D4 in the numerator, you need to plug in G4 in the, G4 in the denominator. Okay, G4 in the denominator. So make sure to match the measurement in the numerator with the measurement in the denominator. Okay, this should be G4. If you use D4 in the numerator, plug in G4 in the denominator. So plugging in the numbers, my numerator is just the very last dividend found in step 1, right, which is 1.3101 D0. I'll divide it by 0.12. 0.12 minus G4, that's 0.04. So that's the same as 0.08 in the denominator. Then I will go ahead and use this output that I already have in my calculator, and I will divide it by this thing's always in the way, 0.08. Okay, so my P3 equals to 161763 times D0. Okay, so we're pretending that the D0 isn't there, but it is still there. Well, let me move this to the right. There we go. 16.3763 D0. Okay. So that's the end of step 2. Now, what is step 3? Step 3 is to use the relevant cash flows that we have calculated in steps 1 and 2 to find your NPV. Well, that net present value is your P0. Okay, so net present value is your P0. And what is your P0? It's given to us. It is $28.89. Remember? Okay, it's here. Okay, so let's do this. So first of all, let's identify our relevant cash flows. So in step 2, we know that we can sell our stock in year 3 or at the end of year 3 at this price. So that means we have only 3 relevant cash flows 1, 2, and 3. There's no cash flow 4. Okay. So what is your cash flow 1? Your cash flow 1 is just your D1. And what is the D1? 1.08. We know that the D0 is still here, but we will temporarily assume that it's not there. Okay. What is our cash flow 2, which is our D2? It is 1.1664 times D0. What is our cash flow 3? Our very last cash flow consists of the dividend in that period plus the stock price in that period. So given we're solving for cash flow 3, we need to have D3 plus P3. Okay. So our D3 is this number, 1.2597 D0. And what is our P3? To give some space, I'm going to erase something here on the right. Okay. So my P3 is what I calculated in step 2, which is this number here. Okay, plus 16.3763 D0. So D0 is in every single term, but we're going to assume that the D0 is not there. Okay, so let's find our net present value. Let me move this to the left. Okay, so cash flow, second, clear work. Cash flow 1 is 1.08, right? It should be 1.08 times D0, but again, we will assume that the D0 is not there. So enter, down arrow twice. To enter cash flow 2, we'll enter 1.1664. Enter, down arrow twice to enter cash flow 3. And I have 1.2597 plus this number 16.3763 equals. So my cash flow 3 should be 17.6360 D0. Okay. So I will now press the enter here, enter key here. To calculate for the NPV, I will enter my discount rate, and it's the same 12%. So 12, enter, down arrow, compute. So that tells me my net present value is equal to 14.4471 D0. So now we're almost there. So if we're told that the current price equals to $28.89, well, that current price is also equal to 14.4471 times D0. How do we use this information here to solve for D0? I hope it's obvious. We'll now divide both sides by this number to solve for the D0. Okay, so that means our D0 equals to $28.89, the P0, divided by the 14.44. Okay, I think the monitor at the corner here, it's one. There we go. It's broken, so it doesn't sense well at all. Now, to avoid rounding error, I will keep this number in my calculation. So I will press the cancel key one time here at the lower left-hand corner to keep this number, but just to get rid of the NPV. So this is our denominator, right? Well, currently it is entered as the numerator. So I will invert it. Okay, I will press the 1/x key to change it into a denominator. Then I will multiply this number by the numerator, which is 28.89. So my my D0 is this number. And since we're talking about money, we will round off the final number to the nearest cent, which will be $2. Okay. $2 even. Okay. $2. So that is your D0. So if you are asked to solve for D0, you are done. But what if you are asked to find D1 instead? If you are asked to solve for D1 on the exam, then you need to, first of all, do the exact same things like what we have done so far, going through the 3 steps to find your D0. Then you're going to do one more step, which is to convert your D0 into D1. How? D1 equals to D0 times 1 plus G1. Okay, so given $2 as my current dividend, I will multiply it by 1.08 because my G1 is 8%. So that'll give me the $2.16 as my D1. Okay, so I can assure you that on the exam, I will ask you to solve for either D1 or D2 by using the variable growth model, okay, at least one of them. So read the question carefully, okay, because with the multiple choice questions, if you solve for one, when I ask for the other, you can spend all this time and end up with no point at all. Okay. Erase this. I'm going to assume that you're done copying, so I will erase this here as well. Okay, so one more. So with the two earlier dividend models, other than solving for P0, we also solve for the R, right? So same thing here. Let's solve for the R when we have variable growth model. So the current stock price is $28.89. Just to keep it simple, I'm using the exact same set of numbers, okay? So this is our current stock price. So this is our P0, right? That's also known as the net present value. So while the current dividend is $2, so that means this is our D0, okay? Dividends are expected to be $2.16, so that's our D1. Well, let me save the space, so I have space for calculation later. Let me move this here. So this is our D1, $2.33. This is our D2, $2.52. That's our D3. And $2.62 is our D4, okay, for the next 4 years. So the stock price is projected to be $32.75 in 3 years. So that means this is our P3, okay? When we say in 3 years or in year 3, we mean at the end of year 3. Okay? While the dividend growth rate is anticipated to be 4% per year, again, it indicates something's constant, right? Starting in year 4. So that means G4 and after equals to 4% per year. Okay, 4% per year. So based on this information in this particular sentence, it says dividend growth rate is anticipated to be 4% per year starting in year 4. It is implying that before year 4, the dividend growth rate is not constant, right? So that is a good indication that we have variable growth scenario here, which tells us that we need to use that 3-step approach. Now, if you want to be stubborn, you say, well, just because we're told that the dividend growth rate is going to be 4% starting in year 4, we don't know with 100% certainty that it is not 4% before year 4. Well, if you are insisting on calculating for your G1, G2, and G3, you can still do that. The growth rate is just rate of change, right? Rate of change. Just think of the capital gains yield that we have learned how to calculate in the past. So the capital gains yield measures the rate of change in your price. So I'm going to use initials, okay? Capital gains yield equals to the percentage change in price. Change is notated by delta or a triangle, percentage change in price. And mathematically, how is it calculated? P1 divided by P0 minus 1. So now if you want to calculate the percentage change in dividends, for example, if you want to calculate G1 growth rate, dividend growth rate in year 1, you have to, rather than using price, you have to use dividend. So D1 divided by D0 minus 1. Specifically, what is my D1? 2.16, $2.16. What is my D0? $2 and minus 1. It will give you 8%. Okay. So the growth rate is just rate of change. So if you remember how to calculate capital gains yield, which is the rate of change in stock price, you can just change the notation to solve for the rate of change in dividends. Right. So obviously now we have more than one growth rate. Okay. So when we have more than one growth rate, we have variable growth scenario, and therefore we must follow that 3-step approach. So what is step 1? Step 1 actually has been completed for us. Step 1 is to find all future dividends until the growth rate becomes constant, right? So that has been completed for us because we're given D1, D2, D3, and D4. So we can move on to step 2. Step 2 is to apply that constant growth equation to the last dividend found in step 1. So if we know that D4 is $2.62, we're plugging D4 into the constant growth equation, we can find P3 in step 2. While fortunately, again, P3 has been calculated for us. So technically, steps 1 and 2 have been completed for us. So the only thing that's missing is step 3. But we have to modify step 3 because we're not solving for the P0. We're solving for the R. We're solving for the R in this particular problem. So what is step 3? Step 3 is traditionally is to enter all the relevant cash flows to find net present value, right? But now we're going to enter all relevant cash flows, not to find the P0, because we're not solving for P0, we're solving for the R. So we have to compute for, CPT is compute, right? Compute for IRR. But if someone have problem with this calculating for IRR, it is because they forget to enter cash flow 0. So in order to calculate IRR, we need to incorporate how much your investment is. And your investment is the price that you pay for the stock right now. So cash flow 0, it is an investment. So you have to make sure to enter it as a negative cash flow. So negative 28.89. Your cash flow 1 is just your D1, which is $2.16. Your cash flow 2 is just D2, which is $2.33. Now your very last relevant cash flow is cash flow 3, right? Because we know what P3 is. So we know we can assume that we will sell our stock at the end of year 3 at the $32.75. So the very last relevant cash flow is cash flow 3. So the very last cash flow has, again, 2 components, right? Dividend and price for that year. So given this is cash flow 3, we need to have D3 plus P3. D3 is $2.52. P3 is $32.75. So together, my cash flow 3 is $35.27. Okay, so let me bring back my calculator. Move it to the right. Let me do it here. There we go. So cash flow, second, clear work. So I have to enter my cash flow 0. Okay, $28.89. I will pay this much to buy the stock right now. After this, I will receive dividend payments. In year 1, I will receive $2.16 as cash dividend. In year 2, I will receive $2.33 as cash dividend. In year 3, I will receive this much cash dividend, and I will sell my stock at $32.75. So you can double check your calculation, but we already know that's $35.27. Okay, that's my cash flow 3. So after I've entered all of the relevant cash flows to find my average annual rate of return, I press the IRR, then I press the compute. It is 12% per year. Okay. 12% per year. Now, there's actually a shortcut to this because this is a simplified problem. So the assumption here is that the return will remain constant throughout your investment period. So that if this is true, okay, if the average rate of return is always the same across different years, so a faster way is, well, if I know my D4 is this number, and I can plug that into my constant growth equation. So D4 divided by R minus G4, it will give me P3. So I know I can rearrange this equation to solve for the R, right? So how do I rearrange it? Step 1, I will swap my price from the left-hand side with my denominator. So I'll now have R minus G4 equals to D4 divided by P3. And now to solve for the R, I want to get rid of the negative G4 and move it to the other side. So I will plus G4 to both sides. So I now have R equals to D4 divided by P3 plus G4. So what is my D4? My D4 is $2.62, so 2.62, divided by P3, which is $32.75, plus my G4, which is 4%. So if I bring back my calculator, move it to the left, just out of the way. So let's plug in the numbers. 2.62 in the numerator divided by 32.75 equals, I now plus the 4% as my G4. This will also give me the R. But this shortcut is only workable if the rate of return is constant. Okay, in the real world, it may not be. Just saying, okay? So in the classroom, we'll always try to simplify a little bit. Okay. All right, so this concludes the lecture of chapter 9. So the homework has been posted and it is due in a week at 5 p.m. Okay.